All right, students, you need to tear out pages 273 through 277. We're working on 5-2 today. Be getting those pages gathered up while I'm talking to you. We started on ratios a couple of days ago, and we've been working on ratios, and ratio is just a fraction that's comparing two numbers. Today we're going to talk about generating equivalent ratios, and for just an example, if I have the ratio 1/2 and I multiplied that ratio by 5, 5 times 1 is 5 and 5 times 2 is 10. Those are equivalent ratios. We did a little bit of this in the last lesson. We're going to be doing a lot of it today. All right, let's read this problem. Sally used all the paint shown below to make certain tint of orange paint. How many pints of red paint should be mixed with 24 pints of yellow paint to make the same tint of orange? All right, I'm going to move up here where I can find a place to work. Okay, right now I see 1, 2, 3 yellow and 1, 2, 3, 4 red. Now I can write this down. 3 yellow to 4 red, or I can write it 4 red to 3 yellow. Doesn't matter which way I write it. But in the reading up here, we want to now grow this mixture up to 24 pints of yellow. So I want the yellow to be 24, and I want to find out the red. How many red? Or over here, I want the 24 yellow would be in the denominator with it flipped over this way, and I want to find the equivalent ratio. I want to know how many would be red. So I'm just going to use this first one. Is there any number that I know of that I can multiply times 3 to make a bigger batch that would be 24? 3 times what gives you 24? Well, everybody should know it's 8. So we're going to multiply times 8 to get 24. So we've got to multiply this times 8. 8 times 4, that would be 32 red. So 3 is to 4 as 24 is to 32. There's the answer. Now, these are equivalent ratios, because if I reduce this back down, it comes back down to the 3 to 4. Now, why did I do that? Because I needed to make a bigger batch of orange paint. This wasn't enough. I needed a lot more orange paint. I needed this much orange paint instead of this much orange paint. All right, if I do this one over here, I would again multiply by 8, and I'd get 32, and there's my 32 red. It doesn't matter if it ends up in the numerator or the denominator. What matters is that you know it's 32 red gallons that you need for every 24 yellow gallons. All right, let's go down here to the focus on math practices. If Sally uses the same ratio of yellow to red, so they said which one to put where, so it's yellow to red. Same ratio. How many pints of yellow should she mix with 16 pints of red? So we want to grow this 4 in a bigger batch. We want it to be 16. Well, 4 times 4 gives me that 16, so 3 times 4 gives me 12. So I need 12 yellow. And there's the answer to that. You have to keep up with this was yellow and this was red. So when I'm finished, this is going to be yellow, this is going to be red, and get your numbers in the correct places. Okay, turn the page over. Page 274, example number 1. We're going to use multiplication to find equivalent ratios, just like we did on the previous page. For every 16 basketball players in Crystal County schools, there are 48 soccer players. If the ratio remains constant, that means the ratio is going to stay the same. It's going to stay 16 to 48. how many soccer players would there be if there are 64 basketball players? So I take my original ratio and I double it times 2. And I double both of them. So if in a twice as many, there'd be 32 basketball and 96 soccer. Go back to your original and multiply it by 3. 3 times as many would be 48 and 144. Go back to the original. 4 times as many would be 64 and 192. Okay, and we filled in the chart doing it that way. So that means that there are 192 soccer players when there's 64. We kept going until we got this number to be 64, and that tells us how many soccer players there would be right there. Okay, another way, which is the way I did it in the first example we had, is to use multiplication. 16 times 4 would give me the 64, so 48 times 4 gives me 192. Okay? Same thing they did up there, they just put it in a chart. If you extend the table above, how would you find the next ratio of basketball players to soccer players? I would take and multiply both of them by 5. Would be 16 times 5, then 48 times 5. $16 times 5 is 80. And then 48 times 5, I believe that's 240. Now, what's the relationship between the number of basketball players and the number of soccer players in each column in the table? Was the relationship the same? Or what is the relationship? Okay, I've read that wrong. What is the relationship? What's the relationship between each pair of these numbers? What's the relationship between this right here? Look here, this 48 shows up here and here. But when there's 16 basketball players, there's 48 soccers. So apparently when I multiply 16 times 3, I get 48. Oh, so that means there's 3 times more soccer players than there are basketball players, because this number is 3 times that one. There are 3 times more soccer players than basketball players. 3 times more soccer players than basketball players. Or you could have said there's 1/3 as many basketball players as soccer players. Either way works. One way it's 1/3, one way it's 3 times. Alright, let's go to page 275, example 2. Sarah made baskets on some of her shots in a basketball game. If she continues to make baskets at the same rate, how many baskets will Sarah make in her next 6 shots? So she's taken 18 shots and she made 12 of them. All right, so they're going to, in this way right here, they're going to make a table and they're going to work backwards till they can get that down to 6 shots. So if I divide 18 by 2, I get 9. If I divide 18 by 3, I get 6. So there's the 6 shots we wanted. So now we got to come down here and say 12 divided by 3 would give me 4. So when she takes 6 shots, she's likely to make 4 of them. So Sarah will make 4 baskets in her next 6 shots if she continues at the same rate. Doing it another way, by what number do you need to divide 18 to get 6? Divide it by 3. So 18 divided by 3 is 6, and 12 divided by 3 is 4. Same thing. Why have we been working on our multiplication facts since the beginning of school? Because we use them a lot. All right, let's look at example 3. Pi is the ratio of the circumference of a circle to its diameter. It's the ratio of the circumference to the diameter. Circumference is the distance around the circle. Diameter is the distance across through the center of the circle. Okay. It says, which of the following ratios are equivalent to 66 to 21? 66 to 21. Well, I know this is divisible by 2. This one's not. This is divisible by 3, and so is this one. So here's what I've got, and I'm going this way. So I'm dividing, so I'm going this way on my chart. 66 divided by 3 is 22, and 21 divided by 3 is 7. Okay, over here, if I take my 22/7 and multiply it by 2, I get this. Multiply it by 3, I get this. Multiply it by 4, I get 88 to 28. So it says the ratios 22/7, 44/14, 88/28 are all equivalent to 66 to 21. These are all equivalent ratios. If you took 22 and divided it by 7, you'd get some number. Let me show you that right quick. Let's just do that. Let me get a calculator. Let's take 22 and divide it by 7. See what we get? 3.142875. Let's clear that. Well, no, let's leave it on there where you can see it. 44 divided by 14, look what you get. 66 divided by 21, look what you get. And 88 divided by 28, look what you get. So these are all equivalent fractions. If I were to divide them out, numerator divided by denominator, I get the same number every time, which is pi. Okay? They ask us to try one down here. Let's try it. Which of the following ratios are equivalent to 16 to 20? So I'm going to put 16 to 20. And I'm going to go down first. I know both of these are divisible by 4, so let's divide it by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. I know those are equivalent. Well, there's one. Which of the following are equivalent to this? So I found one. Okay? If I take this bottom, this last one, and multiply it by 2, 2 times 4 is 8, and 2 times 5 is 10. 8/10 is another equivalent fraction. It's not in this list. Let's go by 3. 3 times 4 is 12, and 3 times 5 is 15. 12 to 15 is not in here. If I go by 4, I get this one. So let's go by 5. 4 times 5 is 20, and 5 times 5 is 25. Now there's one. Okay? These are all equivalent fractions. This one and this one are the only two that's in this list. So what did I do? I worked backwards to get my bottom lowest fraction. Then I said times 2 gives me 8/10. That times 3 gives me 12/15. Times 4 gives me the 16/20. Times 5 gives me the 20/25. There they are in order. This times 2 times 2. This times 3 if you do their charts. But you've got to go down to your lowest form before you can start finding all the ones bigger than that. All right, turn the page over. Key concept. You can multiply or divide both terms of a ratio by the same non-zero number to find equivalent ratio. So I can either divide by something to go down in size, or I can multiply by something to go up in size. Either multiply both terms by the same non-zero, 30 times 2 is 60, 40 times 2 is 80, or divide both terms. Non-zero means it cannot be zero. Non-zero means it has to be something besides zero. Okay? 30 divided by 10 is 3, 40 divided by 10 is 4. So 30 over 40 is the equivalent ratio to 3/4. 30 over 40 is an equivalent ratio to 60 over 80. Anytime you can do either one of these things and make a new one, it's equivalent. All right, let's go to the do you understand. How can you find equivalent ratios? By multiplying or dividing both terms by the same non-zero value. By multiplying or dividing both terms by the same non-zero value. Deshawn says that ratios 3 to 5 and 5 to 7 are equivalent ratios because by adding 2 to both terms you get, did we say anything about adding or subtracting? We said multiply or divide to get an equivalent fraction. So, number 2, let me read it again. Deshawn says that the ratios 3 to 5 and 5 to 7 are equivalent ratios because by adding 2 to both terms of 3 to 5, you get 5 to 7. Is she correct? No, she is not. She is wrong. You must multiply or divide to get equivalent terms. Has nothing to do with adding and subtracting. All right, number 3. What are 2 ways you can find an equivalent ratio for 12/16? You can multiply both terms by the same number or divide both terms by the same number. Let's do it. Let's divide both of these by 4. Let's divide by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. There's 1. Let's multiply by 2. 12 times 2 is 24. 16 times 2 is 32. Those are all equivalent fractions. Number 4. How can you show that ratios 10 to 4 and 15 to 6 are equivalent? How can you show that ratios 10 to 4 and 15 to 6? Okay, so I'm going to put 10 to 4 here kind of in the middle. I'm going to divide, I'm going to go to this direction to the left. I'm going to divide by 2. 10 divided by 2 is 5, and 4 divided by 2 is 2. So I know those are equivalent. Now, to get from here to here, it's multiplied by 2. To get from here to this next column, it's multiplied by 3. 3 times 5 is 15, and 3 times 2 is 10. So they said show how 10 to 4 and 15 to 6, excuse me, that's a 6, not a 10, are equivalent. Well, we just did that. So the first thing that we did was to go backwards. That's 6. 3 times 5 is 15, and 3 times 2 is 6. We went backwards to get this in its lowest form, its lowest fraction. Then we said, okay, by 2 times 2 gets us there, times 3 gets us here. So how can you show that ratios 10 to 4 and 15 to 6 are equivalent? By dividing first by 2, then multiply that equivalent fraction by 3. By dividing by 2, then multiplying that equivalent fraction by 3. So we started here. Here's where we started. We divided by 2 to go this way. Then we used this fraction in its lowest form, multiplied by 3 to get here. Okay, number 5. Do you know how? Complete the table using multiplication to find ratios that are equivalent to 4 to 5. So our first one's going to be times 2. From here to here is times 2. 2 times 4 is 8. 2 times 5 is 10. Then from here to here is times 3. 3 times 4 is 12. 3 times 5 is 15. Then from here to here, it's going to be times 4. 4 times 4 is 16. 4 times 5 is 20. So all of these are equivalent fractions, equivalent ratios. This is just a bigger batch than this. This is a bigger batch than these two. This is a bigger batch than these. Now, it's easier when you have the first one in its lowest form. Then you just go this way. It's not as easy when you have to go backwards. So, we've got to find something that we can divide into these two numbers evenly. So, let's go from here to here. Let's divide by 2. 40 divided by 2 is 20. 28 divided by 2 is 14. Now let's go from here to here. This time we're going to divide by 4 because it's the next number that I know of that will divide into these two. 3 won't do it. 3 won't divide into these evenly. So 40 divided by 4 is 10, and 28 divided by 4 is 7. So here's 3 equivalent fractions. But I had to work backwards on that one. Okay, number 7. 7, 8, 9, and 10. Write an equivalent ratio for each given. Okay, so we're just supposed to look and find something that's equivalent. Well, I know that these two numbers are both divisible by 3. So I'm going to divide by 3. 12 divided by 3 is 4. 21 divided by 3 is 7. Okay, on number 8, it's already in the lowest form of possible, so I'm going to have to multiply and go up instead of going down. So I'm just going to multiply by 2. 1 times 2 is 2. 2 times 3 is 6. So there's my answer for that. There's my answer for that. Is that the only answer? No. What if I'd multiplied by 3? 3 times 1 is 3. 3 times 3 is 9. There's another one. There are multiple right answers on these. Okay, let's go 6 to 8. I know they're both even. They're both divisible by 2, so I'm going to divide by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. And that's what I'm going to give on that one. Okay, number 10. Pi can be approximated using decimals as the ratio 3.14 to 1. Find 3 ratios equivalent to the 3.14 to 1. 3.14 to 1. Okay, I'm going to start with that. I'm going to multiply it times 2. So that's going to give me 6.28 to 2. Now I'm going to multiply that by 3. 3.14 times 3 is 9.42 to 3. Find 3 ratios. Let's go one more time. Let's go 4. 3.14 times 4 is 12.56 to 4. There's 3 more equivalent ratios to the first one. Okay, look at page 277. Here's your practice in problem solving. It's going to be asking you some questions just like we just got through doing on page 276. I want you to work diligently on just page 277 for the remainder of class time. You have a classroom teacher that can help you. You're either going to be dividing to go backwards or you're going to be multiplying to go up to find equivalent ratios, equivalent fractions. All right, get busy. And let's see. Today, this is a one-day lesson. So you're going to do this one practice page, and then you have a vocabulary and a reteaching page that you can work on when you finish that one page in that page 276. Try this on your own today. See if you can figure out your additional vocabulary and your reteaching page. And your classroom teacher will help you work on those. So you have 3 things to do. Page 277 and the vocabulary and the reteaching page. Those are the 3 things that you're working on for the remainder of class time. All right, get busy, and I will see you tomorrow.